So hello everyone, this is lecture 51 for the mathematical physics. In the last lecture we have completed the complex analysis and today we will start vector analysis. And first I will tell you what is the need of vector analysis. So we will study the electromagnetic theory also, EM theory. So in that we need the vector information very much. Why? See, there you have this electric field, magnetic field, you have dielectric spheres, then you need the spherical symmetry, and then you have the wires also in that. In the wires we can apply the cylindrical symmetry, and using the help of cylindrical coordinates and the spherical coordinates we can solve the system very easily. And there you have this gradient term, dot product term, cross product term, delta term, and how do you find this divergence, curl, and all these terms are there. Then you have this infinitesimal length integral, line integral, area element, volume element theta, and all these integrals and differentiations and curl, dot product, these are all depending on the vectors. So if you need to understand them better or the electromagnetic theory better, then first you need to understand the vectors better. So that's why I'm taking this topic. Then we will start electromagnetic theory also, but this is a part of mathematical physics, so it can be question can be asked from here also, means from the different type of coordinate systems. And let's see the syllabus first. So first we will see the introduction of vectors, then we will see the different type of coordinate systems in this, like Cartesian coordinate systems, spherical polar coordinates, cylindrical coordinates. Here we have x, y, z. Then vector can be expressed in ax, ay, az terms. Here we have r, theta, phi. So vector can be expressed in ar, a, theta, a, phi terms. Then we have cylindrical coordinates. Then it can be expressed in r, phi, z terms. So ar, a, phi, az. So we'll study all of them. And then we also see for all these three coordinate system we will see the line element, area element, and the volume element. So how we describe these elements in different coordinate systems. Then we will see that how we can just transform one vector from one coordinate system to another coordinate system, transformation of a vector from one system to another. Then we will see the gradient, how to calculate gradient, what is divergence, what is curl. Then we will see some of the second derivative also of these things. Then we will study in detail about the line integrals, surface integrals, and volume integrals, because there you will need these small terms, means line element, area element, and the volume element. Then we will see some fundamental theorems which are very useful in the mathematical physics and all the physics. That is, first is depending on the gradient. Then divergence, in divergence we have this name, that is Gauss divergence theorem. Then for the curl we have Stokes theorem, and then in detail we will study about the Green's theorem. Okay, so this will be our syllabus for the vectors. So let's start with the introduction. So this first lecture is introductory lecture. So first, you know all of this, but I will go from the zero or the scratch and start from here, that is vector. So what is vector? So a vector can be defined which has magnitude, which has direction, and which follows this addition law of vector addition. So any line or thing which have direction, magnitude, and which follows the vector law of addition is called a vector. And this should follow this, means unit vector is equal to vector divided by its magnitude. So if this is your vector, then this is called the tail, this is called the head, and this length is defining this magnitude, and this direction is this unit vector defining the direction of this vector. Okay, now what are the four basic operations, means these four operations which can be applicable on the vectors, means which you can apply on the vectors. So four basic operations are, first is addition of two vectors. So see how we add two vectors. So if there are a, b vector, then a plus b or b plus a both are commutative, so they both are equal. A plus b will give you same as b plus a, so that's why we call that addition is commutative. So a plus b equal to b plus a, and also addition is associative. So a plus b plus c is equal to a plus b plus c. Okay, so what is meaning of associative? First you will take this vector, then add to this, then in second one you will take this vector and add to a, so they will give you same vector. So that's why we call this addition as associative also. So how we add two vectors? So if this is your head, then you will second will start from here, tail, then head. This final vector will give you your resultant vector a plus b. This is your addition, triangle law of addition. And same, if you take this vector this side, then this will be b, this plus b, this will be a, so this will be equal to this b plus a. So because this is commutative, so b plus a will be equal to a plus b. That's why we are getting same resultant vector from these two sides. Okay, now what is the difference? So difference can be talked in the definition of addition. How? We can add a vector to the minus of second vector, so that will give us subtraction of a minus b. So this is a, this is minus b vector, so this will give you a minus b vector. This is just addition of a plus this minus b vector will give you a minus b. Now see what is the meaning of this minus and all. So this is second operation which we can apply on the vectors, that is multiplication by a scalar. So any vector can be multiplied with a scalar, and that's how it will be defined. Means alpha, this scalar can be greater than 0 or less than 0. If it is greater than 0, then its length will be multiplied with that value, and if it is less than 0, then length will be multiplied, and it will change the direction also, because for the less than 0 it will be negative, so direction will be opposite. And if it is minus 1, then see, this a vector will be minus a vector, and if this alpha is 2, then alpha will give you 2a, so this is length is doubled and direction remains same. So that's how you can see this multiplication. Now these are the two operations, addition and multiplication. Now third operation is dot product and the cross product. So these are the basic four operations. So what is dot product? So basic definition of dot product is, this is scalar, this will give you scalar, means dot product of two vectors will give you scalar value. And what is the definition? Projection of one vector on the other, that value multiply the magnitude of second one, the multiplication will give you dot product. So projection of a on this will be a cos theta, so magnitude of a cos theta multiply b magnitude will give you a magnitude b magnitude cos theta, and theta is this smaller angle between these two vectors. So angle between two vectors is called this theta. So smaller of two angles between vectors when they are connected tail to tail, so tail should be connected, then this angle between them is called the theta. And dot product is given by AB cos theta, where this A and B are magnitude of A and B and cos theta. So this is nothing but projection of A on B, so A cos theta and multiply B magnitude will give you dot product this. Okay, so dot product is nothing but just a simple multiply and a scalar multiply of this vector with this vector. Now see, this also can be written in this form. I told you A cos theta multiply B, so it can also be written in this form, means projection of B on A, B cos theta multiply A magnitude, so that will be same. So B cos theta multiply A will give you same result, this. Now see, if this is your A and B, so what is the theta here? This theta is 110, okay, because this is the inner angle. Now see, if this vector is in this direction, this vector in this direction, this theta is 110. Now what will be the theta for this dot product? So theta will be, we will take this vector here, means we will just make the tail to tail, so it will be like this. Now the angle in this side will be your theta, that is 70. So that's how you can determine the theta. Just make the tail to tail angle, then measure this angle. Now this is your dot product. So if A and B are parallel, then theta will be 0, so AB will be A magnitude B magnitude, and when this theta is 90 between these two vectors, so the dot product will be 0. So here you can see, you can just visualize this also. If this theta is 90, then this will be perpendicular, so projection will be 0. So 0 multiplied with any vector will give you 0. That's how you can say that when theta is 90, then this dot product will be 0. Now the fourth one is cross product of two vectors. So this cross product will give you vector in result. Okay, so the cross product of two vector will give you vector again, and that vector is perpendicular to the rest of two vectors. Okay, so this is nothing but this projection, vertical projection, okay, A sin theta with multiplied with this B magnitude will give you cross product. Okay, so A sin theta multiply B, or the B sin theta multiply A will give you cross product, and this is your magnitude for this vector A cross B, and direction is n cap. N cap is perpendicular to A and B, so you can find the direction with the help of right hand rule. So what is right hand rule? You just curl your fingers from A to B, then the thumb will give you the direction of n vector, like A to B will give you like this. How you can make this, and this thumb will give you direction. So that's how, if A is here, B is here, then you will like make this, and this thumb will give you direction. Okay, so always use the right hand. So use your right hand and move your fingers from A to B via smaller angle theta, then thumb will give you direction of A cross B. So A cross B, if you just find the magnitude of A cross B, what is this? This is area of parallelogram generated by the A and B. So parallelogram is generated by these two, and if you want to find this area, that will be nothing but A cross B, magnitude of A cross B. So A and B are, because this is simple thing, you know what is the area of a parallelogram? This is perpendicular height multiply one of the side, and you see this A sin theta is nothing but this perpendicular height multiply this. So that's how you are getting area from here. So these things are easy to visualize. Now if A and B are parallel, this is parallel sign, then A cross B will be 0 because theta will be 0 here, and if these are perpendicular, then it will be A and B, simple. Okay, now that was all the properties for the vectors, means these four operations are followed for the vectors. Now we will see the coordinate systems. So first is the Cartesian coordinate system. So you know about this Cartesian coordinate system. This is represented by x, y, z. You have three axes, x, y and z. So always remember, you will make coordinate system like this, means x, then it will be y, and then x, y product will give you z. So always make it like this, not like x, y, and okay, that's how. So if it is your x, y, x is here positive, if it is here positive, then z will be in this direction. Okay, so that's how. If this is x in this direction, then y will be in that direction, z will be in perpendicular to x and y. Means if you make this cross product like this, then z will be in this direction. So remember this. Now if you want to represent any vector, so if this is your vector and you want to represent this point, so this a vector will be, means ax in the x direction, ay in the y direction, and az in the z direction. So that will give you this vector a. So that's how you can define your vector in the Cartesian coordinate system. Now how to define a position vector in Cartesian coordinate system. So position vector is nothing but r. So any position vector r is nothing but represented by this coordinates x, y, z. So x minus this, if the origin is here, and then 0, 0, 0 will give you x minus 0 x I cap, means x cap, and then y minus 0 y cap, z minus 0 z cap. So that's how you can determine this position vector. So if this is your O, this is your P, then P minus O will give you OP vector. So that's how you define the vector. Now this is nothing but, if this is coordinates are x, y, z, then this will be x, this will be y, and this will be z. Okay, and this magnitude of this r will be nothing but under root x square plus y square plus z square, because see, this length will be x square plus y square, that is z square, so again it is a right angle triangle, so it will give you x square plus y square plus z square. So magnitude of this r vector is under root x square plus y square plus z square. Now this direction is r cap. Then how to find this unit vector direction? So r cap is nothing but r vector divided by magnitude, so that will give you your unit vector. Okay, that is the direction of this vector. Now see, if we make a small displacement in this P point, make it to the Q, very infinitesimally small displacement dl, then how you determine the coordinates for dl, means how you describe the dl there. Okay, for that is infinitesimal displacement. So let's say we move from xyz to x plus dx, y plus dy, z plus dz. We just move this to dx, this to dy and dz. So this P will be somewhere here Q. So how you describe this dl? So r will be r plus dl, and dl is nothing but, if this is your P point, just make a sphere, make a cube here now, and see this P point at this origin. Now you displace this from here to here. So this will be dx, this will be dy, and this will be dz. So coordinate of Q will be dx, dy, dz. Means coordinate of Q will be x plus dx, y plus dy, z plus dz. But this displacement will be, how you can determine? Means now you can write this dl as, means this is your change in vector or the line vector. So dl is nothing but q minus p. So when you subtract q minus p will give you x plus dx minus x will give you dx. Here it will give you dy, here will give you dz. So dl will be dx, x cap, dy, y cap, dz, z cap. So dl is only from p to q. So that's how you can find this dl vector, and this is this. Now if you need to find the volume element here, so this will be simply dx, dy, dz, because the volume of this small cube will be this. And this is nothing but change in the value. So that's how we determine this d tau. And okay, then in the next lecture we will discuss about the area element also, and we will move forward for the more coordinate systems. So what is the area element? We will discuss about open surface and the closed surface. So what is the open surface? Open surface is something which is covered by a lines. Means like you have a circle or you have the cube. You have circle. Then this circle is covered by the lines, small lines. You have this square, then this is covered or the enclosed by lines. But if you have cube or something, then that is enclosed by surface area, not the lines. You can't close this with the lines. Okay, so whatever the system is covered by area is called closed surface, or whatever the area or the whatever the surface is covered by lines, then that is called the open surface. Like you have hemisphere, so that is open from the, if it is solid, then that will be closed surface. If it is open, means if it is hollow hemisphere, then that is covered by this circle, and circle is covered by lines. So that's how we call that open surface. So that's how you will differentiate the open surface and the closed surface. So we'll discuss more about these open and closed surface and the surface area element in the next lecture. Then today we'll end here. So see these things first and try to understand, then we'll move forward. Thank you everyone.